So in this lecture series on Laplace transform, we're going to see the last type of problem, but this is going to be a long one. So I hope you're ready for this. So what we have is this differential equation. So I'll number it third. So we've already solved two problems. So it's better you watch it in sequence. So this is the third type. So this is the differential equation. And we are to solve this differential equation where the initial conditions are given as y of 0 is given as 2 and y prime of 0 is given as 1. So now this solving this differential equation, now we have to take, as usual, taking the Laplace transform on both sides. Laplace transform on both sides. So we take the Laplace transform on both sides. So the Laplace transform of the second derivative will be now written here in brackets is this term. So and the Laplace transform of the first derivative now is here being written in brackets. And then we have Laplace transform of y. So left hand side we've taken the Laplace transform. So right hand side cos 2t Laplace transform is s by s square plus 4. So it is nothing but Laplace transform of cos of at, where a is nothing but 2. So we get s by s square plus a square. So 2 square is nothing but 4. So right. Now the given initial conditions you have to substitute y of 0. So y of 0 is 2 and y prime of 0 is 1. So then the equation just becomes actually s square L of y minus 2s minus 1 plus 4 L of 8 L of y equal to s by s square plus 4. Now what I'll do is as I did before, I will collect all the terms that have L of y as common. Okay, and I will take all the other terms, the s terms, to the right hand side. So I'll take all the other s terms, so all these minus 2s, minus 1, all these terms will go to the right hand side, and this will get added to this fraction, and I will collect all the s square terms to the left hand side. So sorry, I'll collect all the terms that have L of y. So L of y to the left hand side and all the s terms to the right hand side. So therefore I'll have s square L of y minus, sorry, plus 4s L of y plus 8 L of y is equal to s by s square plus 4 plus 2s plus 9. So if you sum this right hand side, if you sum this right hand side, what you get actually is nothing but, so you have to sum. So you just take the LCM and take the sum. What you actually get is this quantity. What you get is s square by 4 in the denominator, and then you have s plus 2s cubed plus 8s plus 9s square plus 36. So this is what you get on the right hand side. And left hand side, I will take as usual L of y common, and I'll write out the remaining terms inside. Collect all the remaining terms and write. So L of y is common, and then I have s square plus 4s plus 8. So this is what I have. Now obviously this has to now go to the denominator. So this term will now go to the denominator. So we have this in brackets, and this term now goes to the denominator. S square plus 4s plus 8. This term goes to the denominator. So now obviously what I have to do now is you have to multiply both sides by Laplace inverse, such that the right hand side multiplied with Laplace inverse and Laplace transform, the forward transformation and the backward transformation, just becomes y. So this is y. So y is nothing but the Laplace inverse of this quantity. So our problem now, solving this differential equation, comes down to finding the Laplace inverse of this quantity. So that is what the rest of the problem will, this video will entail, of finding the Laplace inverse of this quantity. So what this entails is writing this in, again, splitting this as partial fraction. So splitting this fraction as a partial fraction. So let's see how to split this as a partial fraction. So what we have, the fraction that we have is 2s cubed plus 9s square So what we have is 2s cubed 9s square plus 9s plus 36 divided by s square plus 4 and s square plus 4s plus 8. So how to split this as a partial fraction is in this way. So we take as plus b divided by s square plus 4. So this is the third methodology you're learning in splitting partial fractions. So whenever you see an s square here at the bottom, you have to split it this way. So here again you have an s square, so you have to split it this way. You have to give it two constants, and one constant gets tagged along with s, and you have the denominator. So now again this will just be like our previous methods. You have to solve for the constants a, b, c, d. So the denominators will be the same. So the numerators you have to equate, and here we will use a different method of collecting the coefficients of each term. Okay, so collecting the coefficients of s, so each power of s. So we collect the coefficient of each power of s and we'll equate. So obviously the left hand side, so since denominators are equal, we will have to say the numerators are equal, and then we will go ahead with equating the coefficients. Now, as I said, the denominators are equal, so the numerators have to be equal. So I will just equate the numerators. So numerators are equated. Now, what we will do is we have to multiply these terms out. You multiply these terms out. You multiply these terms out, and when you multiply them out, let's multiply them out. So when I multiply this out, what I actually get is, this is what I get. So when I multiply this out, what I get is a square plus 4as square plus 8as plus b square plus 4bs plus 8b plus cs cube plus 4cs plus b square plus 4b. Now what I'll have to do is I'll have to collect all the coefficients of s square, s cubed, s square and s and the constant. So I'll get four equations. and I will have 4 unknowns A, B, C, D. So I can solve the equation like in that way. So I have to collect coefficients. So on both the left hand side and the right hand side and just equate them. So collect the coefficients of S cube, S square, S and constant term. So just collect and equate them. So the S cube coefficient is 2 on left hand side and A and C on right hand side. And we have S square coefficient is 9 on left hand side, and then we have 4A plus B plus D on the right hand side. And S coefficient is 9 on the left hand side, and we have 8A plus 4B plus 4C on the right hand side. So 9 on the left hand side and 8A plus 4B plus 4C on the right hand side. So that's what we have. And then we have constant term is 36 on the left hand side and 8B plus 4D on the right hand side. So we have 4 equations and 4 unknowns. We'll just have to solve for A, B, C. So when we solve, what we get is the value of A is found to be 1 by 20. Value of B is found to be 1 by 5. Value of C found to be 39 by 20. And value of D is found to be 43 by 5. So now we have to substitute this back in this equation. So this equation was only simplified to this equation. So we substitute back the values of A, B, C, D into this equation, and we have to find the Laplace inverse of that equation. So when we find the Laplace, we have to find, so to find Y, we have to find the Laplace inverse of so this just simplifies to now Laplace inverse of, so we just split this. Okay, so we just split the two terms as 1 by 20. So we just split these into two terms. So 1 by 20 multiplied by S by S square plus 4 plus 1 by 5. So this term. So again, we split this equation into two terms. 1 by 5. 1 by 5 square plus 4. And this will keep as a separate term, and then the Laplace inverse of the remaining 39 plus 39s 20 plus 4s by 5 s square plus 4s by 8. So the Laplace inverse of this quantity is nothing but, so s by s square plus 4 Laplace inverse is nothing but cos 2t. Okay, and so and the Laplace inverse of 1 by s square plus 4 is 1 by 2 sine 2t. So this inverse transform alone, let me do this separately so that there is some time spent on this inverse transformation. So let's take the first case, the inverse transformation of this first quantity. So that is actually directly through the formulas that we've learned. So the inverse transformation of 1 by 20 is already outside. 1 by 20 is already outside, and we have s by s square plus 2 square. Now, the formula is cos AT is equal to s by s square plus a square. So the inverse transformation will obviously be cos AT, and in place of 2a we have 2 here, so this be cos, sorry for that, it will just be cos 2t. However, the next one we have 1 by 5, the Laplace inverse of, so this will be actually 1 by 20 cos 2t. Yeah, 1 by 20. Next one is 1 by 5 Laplace inverse of 1 by s square plus 4 square. So what is this? So we know sine AT is nothing but a by s square plus a square. So what we have on the right hand side is nothing but 1 of the form 1 by s square plus a square. So therefore this will just, you just take the a to the denominator, so 1 by a will be sine a. Now this is of the form 1 by s square plus 4 square. So in the place of, sorry, not 4 square, 2 square. So this is 2 square. So this is of the form 1 by s square plus a square, which is of the form a square s square plus a square. So in the place of a we have 2. So you just substitute. So wherever, now in the left hand side you just substitute wherever a is there 2, that will be your inverse transformation. So 1 by 5 is already there, and then we have 1 by 2 sine 2t. So this is your transformation. So this will actually become 1 by 10 now. So we found the Laplace transform of the first two quantities here. Now we have to find the Laplace transform of this quantity. So that is what we'll do in the next step. So the Laplace transform of this quantity, 3920s plus 43 by 5 divided by s square plus. About that, s square plus 4s plus 8. So we have to find the Laplace inverse of this quantity. So what we'll do actually is, we'll actually use this formula. We had already studied, if f of t, the transformation, Laplace transformation of f of t is f of s, then if you're multiplying it by e minus at of f of t, then we replace f of s by s plus a. We replace f of s by s plus a. So what I'm going to do here is, I'm going to multiply this left hand side. I'm going to multiply. So this, now the, so we are finding Laplace inverse of this quantity, and let's say this is equal to some function of t. Now if I multiply that some function of t by e minus at, I have to replace in the left hand side, wherever s is there, I will replace by s minus a. So 39 by 20 s minus a. So in place of s, what I will put is, in the place of s, what I will actually put is, I'll put 2. Okay, I'll actually put, in the place of a, I'll put actually 2. And this denominator, instead of writing s square plus 4s plus 8, I will write it as plus 4 plus 4, and I'm going to group the terms, and I'm going to write it as S square plus 4s plus 4, I can write it as the first three terms, I can write it as s plus 2 the whole square. And this last term 4, I can write it as plus 2 square. So I'm simplifying it and writing it. So now coming back here, I replace s by s minus 2, because as I said here, I replace s by s minus 2. I'm going to here I'm going to multiply by s e to the power 2t. So if I'm multiplying by e to the power at, I replace by s minus a. So that is what we do, e minus s minus. So I'm multiplying by e to the power 2t, so I replace s by s minus 2. So wherever s is there, replace by s minus 2. So this just becomes actually, so this just becomes so this just becomes s square plus 2 square. This quantity just becomes s square plus 2 square. So now we can easily find the Laplace inverse of now this quantity by just simplifying this equation. So what I have now is, so multiplied e power 2t, so therefore this side also I have to multiply e power 2t. So the Laplace inverse of this quantity is nothing but, so I multiply this out, I get 39 by 20 s minus 78 by 20 minus 43 by 5 divided by s square plus 2 square. So this numerator now, after simplifying, it becomes plus 47 by 10. So now I have to find, I'll split this term as two fractions. Split it as two fractions and I'll write it. So e power 2t Laplace inverse of e power 2t. There's 39 by 20. I will pull it out and I'll find the Laplace inverse of s by s square plus 2 square. And then I have to find 47 by 10. I'll pull it out and then I have to find the Laplace inverse of 1 by s square plus 2 square. So the Laplace inverse of, so the Laplace inverse of s by s square plus 2 square is nothing but cos 2t. So I can write it out here directly. So it is nothing but cos 2t. And Laplace inverse of 1 by s square plus 2 square is nothing but sin 2t. So we have it. So we have now these two terms now. So we have these two terms and the inverse terms that we found out here. So that will be our answer. The final answer will be these two terms and these two terms. So I'll write out the answer here itself. So first we have 1 by 20. So y is the inverse. We found the inverse of this big quantity. So the inverse of these two terms is nothing but this term, 1 by 20 cos 2t plus 1 by 10 sin 2t, and the inverse of this next quantity is these two terms that we found out. So these two terms are nothing but 39 by 20 e power 2t cos 2t plus 47 by 10 e power 2t sin 2t. So this is our answer. So this is our final answer to this differential equation that we've solved using Laplace transformation.